Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 911 online election. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes before jumping into the solution. So let's get right into it. What problem is asking? That you are given array, two arrays, basically a person array and the times array. Let me write an example so that I can explain it more detailed way. 10, 15, 20, 25, 30. So this one is the person array, this is the time array. So what we are given is at this certain time this person is voted, at time 5 person 1 is voted, at time 10 person 1 is voted. So this much is clear, the significance of person array and the times array. So other thing is that what problem is asking is to return which candidate was leading at a certain given time. For example, at 3, which candidate is leading? I think 0 person or candidate, whatever it is. At time 5, which one is leading? I think 1. Why? Because in the case of tie, what we do at the time 5, 1 is also 1, no sorry, 0 is also 1 and 1 is also 1. At the time of tie, whichever candidate is voted recently will be output. So what we output over here is 1 because 1 is voted. For example, if we take 6, then also 1 is voted in. Or if we take 11, t is equals to 11, which one is leading? By that time I is 2, so what we return is 1. So that much is pretty clear. How we gonna, what problem is asking and what are the outputs? So first thing first, we need to have the count or the votes of the person, that is for sure. So which data structure we can use to have a person count of votes? I think hash map, isn't it? Or better, we can use hash table. Let me see the not time constraints. Yeah, person is 1 to 5,000, so we can use hash table because it gives little better complexities. So what we do is, with the given person, we store their frequency index. At that person index we store their frequency, that that is very basic programming. So that much we have taken care. And what else we have to do is, at a given time t, which one was at lead? We need this also. Why we are doing this beforehand? Because you are given a query for, let me take a example. In this function, what you have to return is, at a given time t, which candidate was leading. So why we are doing this? Because of this, you need to give answer fast, so you have to have your pre-calculation, some pre-calculation done. So that's why we are doing it. This is the way we do query question, because something has to be calculated, because you are given certain calls and you cannot do the whole calculation at that call only. So that's why we are doing. So let's get back to it. Where were we? So so at t, So at T we have to store which candidate was at lead. So how are we gonna do it? Very basic thing. For that we also required hash map, because at the time T we are storing something, so key value kind of condition, so that's why hash map is good. What we will do is, little algo, what we will do is take a max for the initial condition, like take a person 0, because person 0 will be the max for that first iteration. Take the person 0 and we will see if the current count, the vote count, the count that we are saving over here is, if it is greater than the max, what we will do is current count. If it is greater than max, what we do? We change the max to current count. That's what we do. And also current count is this much, and we will have the person, which person did have that count, so we will store over in the timestamp hash map. Let's call that hash map timestamp. So whichever person at that time was the max, whichever person, we will get that person time and that person, whatever it is. We can figure out this syntax and all that in the coding part, timestamp. So what we are doing is, I just told you the algo part. What we do is take the max, let the max be the person 1, and we will keep on checking if max is updated. What we do, we update, we update the max, and also while doing that we update the timestamp for that given time, that this time this candidate was leading, so this much is stored. So what we have the, what we did, we counted the votes. Why? To implement the timestamp. What is timestamp? Timestamp is a hash map where we are storing that this person at this given time was at lead. So why we calculated this? To find this. And why we calculated this? To answer our query, to implement this function. So let's see how we're gonna do it. So if you saw carefully what we were doing it, we were giving query at time 3 which candidate we should return, at time 5 which candidate we should return. So you see, even if 3 is not available, we return 0. If 5 was available, we return 5, whatever was stored at 5. You see, if at 6, what we still return is 1. What we still return is 1. So we are always searching this t. If this t is present, return whichever candidate is present at that particular time. And if not, what we do? Let's take a 6. At 6 is present nowhere. 6 is present nowhere, but what we did over here is we returned 1. So what we do is, if it is not present, we check back, because in this time interval 10 to 15, sorry, we are 5 to 10, at this interval person 1 was the candidate which was most voted. So even if we 6, 7, 8, person 1 will be the candidate So how are we going to do it? We will be using lower bound. What lower bound does is, if it is present, it return that iterator. If it is not present, it return 10. For example, 6. It was not present, so it will return 10. But what we can do is, we can get to the previous, because why? Because the previous is the timestamp where the candidate was decided, and for that 5 to 10, that candidate was the most voted candidate. Am I right or wrong? Am I right or wrong? Right. So what we do is, we use lower bound. What lower bound does is, if present, what you will get is that value, that iterator. If not present, you get a iterator, but at greater than the t, iterator. So if this case happen, what we have to do, we have to just look back, because I already discussed, because that in the mid interval, that candidate was the max voted, so we have to return that. So both the function are pretty much clear, discussed. There is no algo part. I have already discussed the algo, what we will be doing. Let's see the code, and I will try run the code. Why do things two times? I will try run the code, and you can understand. So this is uh, this is time lead, or timestamp, that we were discussing. Why I used map? Because there is no lower bound function on unordered map, so that's why. If you make a point that time is always in increasing order, why use map? But there is no lower bound function at unordered map in C++. I don't know about other languages. So that's why I took time lead and also made a global, because it is needed in the queue also, the query function. So what we do at the top candidate function is basic initialization of n. What, as I discussed, the current max, we take person 1 as the maximum. It will be the, for the very first time, which one is voted will be the maximum. The vote count, as discussed, the hash table. What we do, we keep on iterating, counting the person's vote. The person vote is counted, as you can see. If the current person, this is the current that we discussed, if it is greater than equal to, why I did greater than equal to? Because in the case of tie, whichever is the recent, we have to store that, so that's why I did it. If it is greater than the current max, we update the current max. Now also what we do, we keep on storing the time lead. What do I mean by time lead? At that certain time, which candidate was the maximum, and current max, you can see, is the person only, not the index, is the person only. So we are storing the person. That much is clear. Now in the query, the queue, what we do is, we do a lower bound on the time lead, our map, and if the first key is the time, if the time is equals to t, we are given t over here. If it is equals to t, then no problem, just return the second is the person, as you can see. But if it is not, just go a back and return it. So that much is pretty clear, as I discussed. Let's dry run this code also, so have a more understanding. Yeah, let's have that code over here. Let's have our test case also. and paste it over here. Paste. Yeah. So as you can see, you are given a person array 0 1 1 0 0 1 0 and a times array 0 5 10 15 20 25 30. So what we do is keep on counting. For the very first time, current max is 0, not the 0th index, 0%. And let's go. We get into the first loop. We count the votes. Person 1 0, it is 1 now. It is greater than current max, greater than equal to, it is equal to, but we will do it. And let me write it over here. What is this? This is vote count and this is time lead. So at 0, which one is leading? 0. At time 5, vote count of 1 is also 1 and current max is person 0 with votes 1. Votes, I write it, votes 1. Person 0 with votes 1. Now 1 is also 1. Person 1 is having 1 vote. So at the time of equal, we again change it. Now at the time 5, which one is at lead? Person 1. At time 10, again which one is voted? 1. So 1 is now to 2. And which one has at lead? Still the 2, not the 2, the 1. At the 10, it's the 1. Person 1, which is at the lead at 15. At 15, both tied, but which one is the recent? 0th at 15, 0th at lead. At 20, again 0 is voted. Now it's 3. At 20, it's still 0. At 25, again 1 is voted. Now it's 3. Tie. Which one is the recent one? I would say the one, the person 1. At 30, which one is voted? 4. At 30, 0 is voted. Now vote for 0 counts to 4. 34, not 4. 0. We have to write the person over here, not the vote count. So after that, iteration is completed. We filled our time lead. So this much is what we have to look forward. This is the most important thing. Now let's change the pen color. And again, now we are given queries. And queries, you are given the time t, at which you have to return which one is the person at lead. At 3, 3 is not present. With what will you get is 5, but we don't need 5. We get it backward. 0 and from 0 to 5, which one is at lead? 0 na, so we have to return 0. So what we return is 0. 12, is 12 present? No. What we get from the lower bound? 15, but we don't require 15, we require 10. So what we do is low minus minus, we go to 10, and what we return is 1. 25, is 25 present? Yeah, 25 is present, we just return it 1. 15 is present? Yeah, it is present, we just return 0. 24 is present? No. What we will get is 25, we will just go back. At back, what we have? 0. this we will do. And last one is 8. At 8 is present. No, what we will get is 10, but we don't require 10. Why don't we require 10? Because 8 falls in between, and before 10, which one is the max? Voted person is the one. We just return it. As you can see, same thing. So our dry run was perfectly successful. So let's submit it and see if it is running or not. Submitting or not. Yeah, it is submitting. I hope I was able to make my intuition clear, and if I was able to make you understand this problem and I did contribute to problem solving, so please consider subscribing to this channel, liking this video, and sharing with others. So you have to do what you have to do. So keep grinding. Keep grinding. You guys are awesome. See you in the next one. Bye bye.